regular expressions. Regex. So what is this regex, or also called as regular expressions? What do they do? So these regex, short form for a regular expression, is a string of text that lets you create patterns that help match, locate and manage your text. Especially in our NLP, we have to work with text data. We will be having text, and these regex can be used to search, extract, validate or transform text based on specific patterns or specified patterns. And this pattern can be as basic as for searching a comma, or you can write some complex patterns to validate even a email address or validate a password and all. Especially if you type your password, okay, you can use regex to verify whether it is a correct password or not, which is something like whether you have a uppercase or lowercase, whether you have a digit, or also you finally also have a special character. These are some requirements, as well as your password length should be of size of a minimum of 8. So these can be done with our NLP. And why especially NLP is utilizing regexes? It is going to use to search the text. Maybe in case if you are collecting data from web scraping from open source, we can use regex to extract information from it. Or if you have, for example, you have a tweet data set, you have a data set which contains about tweet. So in tweet, what all we have the tweet, maybe they have the user ID, and they also can have the hashtags as well. So you can collect all the hashtags by simply searching for any word which is having or starting with a hash symbol. So like this, we are going to write some common patterns, okay, which could be something like this. This is a pattern which is a string. These are explanations, and this is the pattern which is used to match an email address. So how to write this? What is the syntax of it? It could be difficult, the basic. Just learn what means which. So later on, when we move into projects, when we imply it in practical application, we can easily use it. If we know the basics, then we can implement it. We just need to know that what means what. Okay. So if you have /w, or if you have dot, if you have underscore, if you have plus, what does that mean? So that is what we need to know. And let us going to do it now in a text. And regex, why we need to use this is it comes in handy in NLP, especially web scraping, data validation, text search and manipulation, etc. And software developers, data analysts or machine learning engineers need regex at one point or other point, and it's almost inevitable. So Python has this already pre-built. It's a built-in package. You can import it in the name RE, which can be used to work with regular expressions. And you can use these options as well. You can use search or find all if you want to find multiple. For maybe if you are searching for all the emails in a paragraph, you need to use find all. If you are just searching for one result, you will be getting the first match. You can substitute it as well, and you can get a full match as well. So in all these things, a common thing are pattern and the text. So the first, you are passing a pattern, and then you are passing the text which you are going to search. So what is this pattern? If you know that in Python, you can simply imply this, that's not an issue. But if you planning to look at this, see here, in regular expression, a pattern is a sequence of characters and meta characters that define a specific search pattern. And the pattern is used to match and search for specific patterns in a larger string. And these patterns can be combined and modified to create more complex expressions that can match a wide range of strings. For example, these are some of the sample patterns and their respective use case. You can find the letters, numbers and hyphens with a pattern, and you can match a date with this pattern. You can match like the final output. It could be if you are searching for a JPG file or GIF or a PNG, you can search from that. You can search from any number between this. You can validate a valid hexadecimal color code. You can also validate a password which should have 8 to 15 character string with at least one uppercase letter, one lowercase, one digit and all, or email address, or searching for HTML tags. These are some common use case. And we are going to use this site actually, which is regex 101, where you can actually visualize this. And regex is something like it is available everywhere. Okay, if you want, you can go into your any of your VS Code or some text editor. Let me show you with VS Code. So we have some data set here, and what we can do is, if I want to just search it, I'll be writing Control F, and if I search for something like Chennai, it is going to show me all the 515 entries it is available, all are Chennai. So if I just press enter, it is going to take me through the word which is Chennai. So you are searching, which is this is raw text match search. You can also enable this, which is use regular expression. Like this, every text editor has the regular expression option as well. So you can click this to find patterns. Maybe for example, if you want to search for numbers alone, you can use /d, and you will be now suggested with all the numbers. See here, it's suggesting 7. Then it is finding all the numbers, right? So we can match something like this. This is very basic, but this is how the regular expression works actually. This we can. This is the pattern we are writing right now, and this patterns can also be practiced here. So that later on, what you can simply do is you can pass your text and your pattern to finally match it. So once we learn the basic patterns, we will be implying it in Python. Before that, this is actually a site. Regex 101 is actually used to build, test, and debug. And this regex is available in all these programming languages. We will be choosing Python. The pattern is common in everyone, so you can learn and implement it. Since our applications are dependent on Python, we use regex on Python. And we have something known as anchors, character classes, ranges, quantifiers, assertions, and all. So we'll be implying one by one in a practical example. So let us go into the site called as regex 101. You can search in the Chrome. You'll be getting this, and you can have your sample text here, and you can write your expression here. Select Python in the left side. You are ready to go. Write your pattern. Write your text here. You will be getting the match information. You also have a quick reference as well, it seems. Fine. So now we are going to just copy this first example. So let me just copy this. This is my sample text which I have, and these dots represent the spaces. Okay, if I add another space, I will be getting dots. That's fine. So now we are going to write our first pattern. In your regular search, what we will do is you will write, for example, if you want to match cat, you will be searching cat. You will be getting the exact word where it is, right? When you go with regular expression, you can do something like this. For example, let me create square brackets, and inside I am going to write a-z. So if you look at or interpret this, if you look at the right side and see what all matches I am getting, and whatever matches you get the blue color which is highlighted. So if you go through this, you can see it is matching all the alphabets between A to Z. That's what this a-z inside a square bracket means. So if you just type without this, you won't be getting it. And if you search A, you will be getting all the A. If you search AZ, you are probably searching combination AZ, or if you search AT, you will be getting the cat at. Okay. Or if you want to match between this, you can go with A to Z. Maybe if I want to match till A to E, I can pass E inside. So what I am getting is all the A from between A to E, I am getting all the suggestions. And still the capital letters are not matched, the uppercase. So if I want, I can go with capital A to capital Z. I'll be suggested with all the capital letters which I am having. So this is inside square bracket. Maybe if you want to choose multiple, you want to search maybe something like A, E, I, O, U. So if you explicitly enter as well, it's like what all things inside this, it will match, and you will be getting all the A, E, I, O, U's in your text. And you can also play with this furthermore. First, let us, for numbers as well, we have the number in our text, right? So you can go with 0 to 9 to get those numbers. If you want to match capital A to capital Z as well, you can write that together, or small a to small z as well. So you are matching the entire thing, right? So this is fine. This is how you will denoting the range as well, or between this is ranges. You can use it to match between this to that. It is easy for us now to search for text or numbers, right? Fine. So now we are going to do one more thing. What I need to have is, for example, I want to have now, I'm going to write combinations. I want to search for a letter between A to Z. and then it is a word actually which has the second letter which is also between A to Z. This is fine. So a two-letter word, what all you are matching getting is, you are now searching for a two-letter word which is A, B, C, D, you are getting all the suggestions. And I wanted to end with something like, then I wanted to end with V. I'm getting Dow represented here because it is what the matching thing is. First two maybe of anything. So if you want, for example, love will get matched, glove will get matched for the four-letter word which is love, or Dow. This, okay, anything you can have. For example, if you change this, it won't match, okay, and the reason is you don't have the V which you explicitly called, and you can see now there is a problem actually. The thing is, you are getting all the suggestions love, love, dow and dow, but here this love is actually from glove, okay, it's not a complete word. Maybe if you are searching for a complete word, then what you can do is you can ask for a word boundary. So you have to use the escape character. I hope escape character is common in all the programming language. We use backslash and then type a character to denote some specific functions inside. So this slash b tells that it is a word character. It is a word boundary. Okay. So you start from a word and this b should also end. Maybe if you look at this, okay, you get suggested like now glove is not matched because you are starting from a new word, okay, word beginning, that's what you are making here. If you look at lovely, I don't want this as well because I want the entire word because it starts anyway freshly but it ends, okay. So here you can add another word boundary to tell that it is a four-letter word now which starts from any A to Z, and the next is any A to Z and then B, so you get love, dow and yeah, so these things. Maybe if you want to match glove, which means it is a three-letter word between A to Z. So now only glove gets matched. So that's how we build this pattern based on the requirement. Okay. So with these things, we are now going to move into something known as quantifiers. So what we have seen now is this ranges. We will be adding furthermore with more complexities later on. We have seen these three. We will be adding more complexities later on. So now we are moving into the basic of quantifiers as well. We will be mixed match so that we can learn. So first the basic quantifiers. So if you use asterisk symbol, then it tells that if you you can't use it without anything, you can't just write asterisk. You will be writing some pattern and then you will add asterisk. Maybe if you are searching for A to Z and then if you add asterisk, then you tell that the previous pattern you are trying to match, right, it can be present 0 times or more than that. Okay, it cannot be present, which means 0 means it cannot be, or it can present any times. If you want to match in that way, if it's optional, then you can give 0, which is asterisk. Then if you go with plus symbol, it tells that it should be present at least 1 times and the maximum can be of any time. Okay, so if you have a pattern A to Z, then plus, which tells that the previous A to Z can be of any time. Okay, but it should be present at least 1. That's what the match will do. Okay, and then you have question mark and the combinations with it. Question marks tells that it's like 0 or 1. It's like a ternary operator. It is going to tell whether it is present or not, 0 or 1. That's what the allowed thing is. Then you can add complexities. This you can ask it, maybe it is or not, this is or not. So you can combine it in that way as well. So now we'll do some more thing like this. First, let us clear this off and let us search for A, B, C, D, E. So what I am getting suggested here is all the A, B, C, D, E which is having. Fine. So first let me add a asterisk symbol. So it is, what we are trying to match here is, it is 0 or 1. Okay. So we are trying to match, it is 0 or 1. Asterisk as I told, 0 or many. Asterisk means 0 or many. It A, B, C, D, E can be present or cannot be present as well. So that's what, it's a doubt situation. So what you are getting is you are suggested by some empty strings which is empty as well. Why? Because you are telling that it's doubt. It cannot be present as well. So here it is not present but still it is matching, and the reason is you have gone with asterisk. But if you go with plus, then you tell that, okay, it can be present at least 1 time Okay, one is must. So that's why now these things didn't get matched. It can be present at least one or more than that any times. So you are suggested with all the single, all the double, triple, all the combinations are suggested now. You can see all the combinations are suggested between A, B, C, D and E. It can be present, it should present at least one times, okay, between one and multiple times. But especially if you go with asterisk, you tell that it is optional, so that matches even the spaces as well. But you can also go with question mark, which once again it's 0 or 1, so you get only the single suggestions, now not the combinations. You can see, right, you get A, B, C, A, C, D, E separately, or it is not present means it is going to empty, so that is question mark. And for example, let us add something like this. I want to find a word boundary, okay, which starts from A, B, C, D, E, and then I'm adding plus, so it can have any number of character, and then I'll add a word boundary as well. So what I'm getting suggested now is any words which contains only A, B, C, D, E, okay, which is A is bad and all. So this is what the words which is suggested. So that's a match, and this is how we use plus. Don't get confused. If you want, please rewatch this once again. This plus we will be using it in many places, and asterisk as well. So it's a doubt situation. It can be 0 or many times, and plus means 1 or many times. That's the idea. So moving into the next example, now what we are going to do is we will be using some negated situation here. So let us learn what is negated. So first, if I use A, E, I, O, U, so I'll be getting all the A, E, I, O, U in my sentence, right? So that is fine. Now, if I want to tell this that find everything except A, E, I, O, U, okay, I hope you understand. If I want to search A, E, I, O, U, I will be giving inside square bracket, I can type A, E, I, O, U, it will be matching everything. But if I want to find other than that, everything other than A, E, I, O, U, I can use this negated symbol. So we are going to neglect these and give the rest. So you can use the caret symbol, which is like this. So what it is suggesting now is you are getting all the things remaining of A, E, I, O, U. You can see the white color. It may be difficult. You can see in the match information what all things match and what all didn't get matched. All the A, E, I, O, U didn't got matched, and we can see the spaces are also matched. Maybe if you want to tell you don't want to match the space as well. So how to denote a space actually is you can use the escape character with small s. So the small s tells that you are matching spaces. Wherever you have space, you are matching it. See here, all the spaces are matched. So if you want to tell that you don't want to match these spaces, okay, along with A, E, I, O, U, I can add a slash s as well, backslash s. It tells that match everything except A, E, I, O, U as well as space. And if I want to find a word, okay, which don't contain A, E, I, O, U at all, which don't have or don't build off vowels, then I can add a word boundary which starts with this, and I can have a plus one or more times and then a word boundary. So what it is suggesting, it is suggesting crypt, dry, and the numbers and the capitals as well. We don't need that. Maybe in the negated we ask it to neglect capital A to capital is it 0 to 9. So this neglects everything and give us crypt and dry, which are words which don't have any vowels inside of them. Remaining things have vowels inside of them. Right. So moving into the next example, next what we are going to see is we are going to complete the quantifiers now. So the quantifiers, we have seen all these, we haven't seen this curly braces. And these are very important and especially useful in a situation like this. For example, let me tell you, I am matching or I am trying to find a word which is of 3 character, okay, 3 letters. It can be of any word. Maybe I can search A to Z, then another A to Z, then another A to Z. So what it is suggesting is all the 3-letter word, and even if I want, I can add word boundary to exactly get the words, right? So A is bad, cat, dry, and E word, all the 3-letter word. So you can see we are repeating the same thing here, which is unnecessary. Simply what we can do is you can type A to Z. This is what you are trying to match. So you can tell how many times you want as well using curly braces. So inside curly braces, type something like 3, which is going to match the previous pattern 3 times. Okay, so you get the same result. A is bad, cat, dry, and eve. Maybe if I want to search a 4-letter word, I can go and pass 4 here. I'll be getting love, dove, away, bed, crow, dove, ends. All these are 4-letter words, right? So like this, maybe if you want, you can also go with 3 comma 6, which what it is going to do is it is going to match all the 3-letter word, 4-letter word, 5-letter word, and 6-letter word. 3 to 6 it is going to match between that. If you want 3 to 4, or if you want to have a minimum which is 3 and maximum of any, you can go with 3 comma, it is going to match all the words which is either 3 letter or more than that. So that's how we will be utilizing regular expression quantifiers here. So finally, before winding up with this particular example, we will be adding one more example to it, which is we are going to discuss about the operators. So in programming language, we have OR operator. Similarly, this is what a OR operator is going to do. It's a straight line which you can add. Maybe if you want to search for cat or bad, you'll be getting both. Okay, so you want to match any of this, you can use OR operator. Similarly, you want to search something like this, where this is called as grouping. You can use parenthesis, and inside you can write either B or C starting and then ending at AT. So if you have a word so known as bat, you will be matched with bat and cat, and the reason is we are matching either AT is the end, it could be either B or C. That's what we are denoting here. If you have something like this as well, it will also work. Something like this. Bat and cat will be denoted. It can be done with groupings. Group have a lot of advantages later on, so we will be seeing that. So bat and cat will be denoted like this. You can use this OR operator. If you want, you can add another one as well. Maybe if you are searching for mat, it will also get matched. That's the idea. So now we are going into the second example. Let me copy this and paste it. Fine. So what we are going to do now is this is actually sentences. We have a lot of sentences. So I'm going to search for a sentence, a valid sentence. So here what I'm telling as valid is a sentence which, once again, keep your attention here. A sentence, it starts with a capital letter and the sentence last word will be ending with a period, okay, which is a full stop. If it ends, I'm going to find it as a complete sentence. So we want to search for capital letters. We can write capital A to capital Z, okay, and we also have something known as dot, okay. This is like something like your plus quantifiers, right? So it could be plus or asterisk. So it matches any character except the line terminator, which is if you are going for a new line, it won't match. Apart from that, it is going to match anything you have. So that is your dot. It's a meta escape character, meta character. So here I can have any number I want from 0 or multiple. So I am going with asterisk here. And then we want to have the line to end with a full stop. If you add dot or period here, it tells that once again the period is a meta character, it matches any character except for line. It won't match this dot actually. So if you want to match that, you have to add a backslash to escape that, okay. So if you want to use any character which already has meaning here, you want to add a backslash and then go with that character, it will be escaped. So now you are matching this. This looks fine, but what if I change this robots into small r? It is not matching. That's really good. If I have a capital B here, it is matching this, okay, but I don't want this to match, and the reason it is matching is it is not checking whether it is at the beginning of the line or at anywhere, okay. So you can have it anywhere. Maybe if you make it small, it is going to match this as well, but I don't want this. Even if you use word boundary, it is going to search for the word only, not the sentence. So here what we can use is we can use the help of anchors, okay. So there is something known as anchors, and this cap symbol, if you guys remember this cap symbol, if you use it inside the square bracket, inside range, it is called as opposite of it or not this, right. So not if you go with ABC, and if you use it inside, it is not A or B or C. Apart from that, whatever you have, it will show you. But if you use it outside, it tells that you are searching for that character which is at the beginning of the line, start of the sentence line. So you are searching that, and dollar symbol is to find at the end of the line. Okay, like the word boundary is here, capital V is not a word boundary. So now we use this, we can simply go and add. We want to have the capital letter at the beginning. So I add this. So now this but didn't match. See here, if I use Control Z, I'll be getting matched with this. If I use the caret outside, I'll be getting proper sentences. And similarly here, if you have a full stop here, this is matching, right? See here, this is matching, but I want a full stop at the end of the line, so I can add a dollar symbol here. So it matches the entire thing, which is proper. So that's how we will be adding complexities and making or fine tuning it. And that is this example. And I hope we can go into the next example. So in the next example, we are going to learn how to match this date. Okay, so we'll be adding or learning more with these examples. So what is the instructions given to us is match the dates which is in this format of month, hyphen date, hyphen year, or you can also have a period in between, or you can also have a forward slash in between. So if you have these things, this is allowed, this is fine. So you can match this. Okay. So you have some dates here, you have some July 20, you don't want to match that, you have 99, this is not any of this format, you don't want to match. If you want to match this as well, then you will be writing separate code for it or separate pattern for it. But for matching this alone, let us do this matching. So we want to first search for a month, right? And here I am going to do one more thing. We will be using some of these expressions which is called as character classes. We have already used it earlier. We are learning more. So every time we add some few more complexity with each example. We have used this small s, backslash small s means if you write normal s, it will search for s, right? So that's why we escape it with backslash s. You are searching for white space. Okay, so we have searched for all the empty spaces, right? So that is s. If you have capital S, it will match all the not white space, opposite of that. And if you want to match the digit, you can go with slash d. This is what I have used in my VS Code to match all the number. Instead of 0 to 9, you can go with this as well. Capital D will match anything which is not a digit, and slash w will search for a word which includes your digit as well as text, and slash capital W will not, which is not a word. And we have for hexadecimal and octal, which mostly we won't use. If you want to take, you can use XSX or O-X. So you can go for this. For example, let us go and utilize for digit backslash D. It is going to search for all the numbers. We are getting the matches, right? I think we had a tab here. You will get all the number matches. Word, you will get all the numbers. Text, capital W, which is opposite of that. Space, which is opposite. This is all the thing which is not a space. This is all the spaces. Now we go with slash D because we want to match the month. Now the month will be of 2. So you can use a curly brace to enter 2 to match all the 2 combinations. Or you can see, you can simply add slash D here. And the reason is, we are using quantifiers to reduce the character count. A to Z, like that. If you keep on adding, it is lengthy. But here, if you mention backslash D, backslash T, it is going to be the same length as your curly brace 2. So it is fine. You can go with any way you want, like this as well. Fine. So you are matching this. And this can have hyphen, dot, or forward slash. So for that, I'll use the ranges, and I'll add some text here. Like it could be forward slash, it could have period, which is dot, and we know that if you add dot, it is going to match anything, right? So we want to escape this as well. Dot, and then we can also have hyphen. So we are matching any of this. You can use groups with OR operator, or you can go in this way. And next we can have D, which is 2, which is the date. And then finally, once again, the same forward slash, dot, or hyphen. And then once again, digits, year of 4. So what it is now suggesting is, it is suggesting all the matching dates we have. It is giving us in the result. So that's what we expected, and it is matched us properly. So that's it. That's the example with our dates. So now we move into the next example. Let us pick this repetitive things. We are going to learn more about groups here, which will be interesting. So now I'll remove this pattern. So Now what we are going to learn is we are going to learn about the next example with the help of groups. So what we are trying to do is we are going to find three consecutive digits which actually repeats in a thing. For example, here we don't have anything like that, but if you look at here we have 999, then 000, then 999. So 999 is repeating again, right? Then here you can see 123 is there, and 123 is repeating again as well. So in this manner we are going to find this first, and in text also we will find it next. First with the numbers. So let us go with this, and let us start typing. So for matching this, I want to have a digit, okay, and I can have or not, and what it is telling us at the beginning, it may be present or may not. Okay, it can be at the beginning or not. I'll later on, after completing, I'll remove this asterisk and I'll show you what happens if you don't have it. Now we are going to use groups, and inside of this group I'm going to group any digit which is repeating 3 times. Okay, combination like number, like if you have 9, then if you have it again, or 1 2 3. Okay, so you are matching any 3, fine. And then you can have any digit in between which is optional. Again here you are telling it is 0 or more than times, it cannot be present or it can be present as well. Then what we are going to do is we are going to enter backslash, and we are going to just add 1. So what this 1 actually do is it back reference to our group. So it is back referencing or matching to our group which you have created earlier. This is first group. If you have another group near to it, later on in text I'll show you the second group. If you have this group, you are matching to the first group with /1. If you have another group to it, then if you want to match the second group, you will be add /2 to back reference to that. So what we are trying to match is we are trying to match any 3 combination which is repeating again. Okay, this is must, and it can or cannot have any number after that. So you can see it is matching the 999, this sentence, and 123. If you just collapse this won't match because we want a combination. And if you ask me why we have an asterisk here, let me remove these asterisks at the beginning and the end. And you are suggested with only the 123 and 123 here and not the 999. Why? Because you are asking it to start with a digit and then it has 3 combination. But here it is not starting with a digit. Okay. And here also first we'll add this. Okay. In ending I'm not going to remove it. Ending is optional. Now in the beginning a digit is must and then the combination starts. This is fine here, but if you look at it, the combination itself starting, you don't have the digit you are asking. Maybe if you add any number, this will match now. See here, any number, this digit is now matching because you are asking it must. But if I go with asterisk, then I tell that that digit is optional. Okay, digit can or cannot be present. Then combination, and in between you can or cannot. Maybe if you have continuously 999, you are telling that this is optional. You can have any numbers or you cannot even have the number. You can have it continuously as well. And then the first match, and then the ending is also, if you here you don't have any number after that, right? But you are telling that it's optional. If you don't have asterisk, that will go. And the reason is after this you are asking any one number. Maybe if you have, that's fine, it will match, or you have to go with the asterisk. That's how the asterisk 0 or more entries, right? Now we'll do the same with the word as well. So we are going to match the word, and here what we are going to do is we are going to match words which is having repetitive things like SS. Here also we have SS, we have PP. Here we have OO, KK, and EE. Here we have GG and SS only. So you can see what we are trying to or going to match is we want 2 letters. Okay, any 2 letters which is repetitive like that. Let us try to match. So for that, let me write W for word. 0 or more than that, it can be present. And then I'm creating a pattern. It's a single word, right? So you want it repetitive, so I'll just add another word. And here I'll add I wanted to match once again, so I'll add /1 to back reference to this guy. Then we'll add W, which is optional once again in between, and then I'm going to create the second group, and this second group can, like, it want to repeat once again, so 2, so it is matching, and then it can have any words in between, and then I'll start another group and I'll match with that same word, and we can have another word as well. which is like optional or not. So what we are getting is we are getting this number, since W will match any word character. I think for Python it matches for number as well. And in Word, what we are actually getting is we are getting the Mississippi and bookkeeping, and we don't get aggressive. And the reason is yes is what the first group matches with one, so another S is there, so we got that. So that is done. Again, another S, that's the second group, and we are matching the second back reference, that is done, and P. Okay, here G and the SS is there. Maybe if you just go with this and not mentioning the 3 will match the aggressive as well. But since you have it, you need to have 3 repetitive things. Maybe if you have E, this will also match. That's what we are trying to do here. So moving into the final example, we are going to utilize this. Then we will go into Google Colab to explore it with Python. So I'll remove this, and now we are going to add another complexity to it. We will learn about assertion. Okay. So what is this assertion actually is? Okay. So assertions are used to like something like look ahead or negative look ahead, look behind and all. So you want to match something and look behind that or look ahead of it what you have. Or maybe if you have some monetary values like money values with dollar symbol, or you have AM, PM and all, you can use it as a best practice here. So first we go and use this question mark equal to, which is the look ahead assertion. So we are going to look ahead of the dollar symbols. I'll create a group and let me add question mark equal to, and we are going to match dollar symbol. And if you know that we have already used this dollar symbol, which is mentioning the end of the string, right? So if you want to exactly match the symbol dollar, you have to escape it with slash. So we are matching this, but we are looking forward or looking ahead, right? So I want to match this. Okay, you are getting the starting point now, but I am interested in the next thing which I have. So I want to have dollar followed by any digit which is plus, which means it should present 1 times or more. Okay, and that's what we are getting now. So we are suggested with only 9, which is single value. Okay, the thing is here we are trying to match the look ahead actually, but we want to look behind to it. So we can simply add less than equal to, so it matches any digit followed by something like this. What we are exactly matching here is positive look behind. So we are looking behind of a digit which behind it has a dollar symbol, and we are getting matched now with 9, 12, 1, 1, so on. So which is actually numbers. So we get all the monetary values, right? And you can still see here the comma is not matched. The million, trillion should also be coming, right? Maybe we can modify this as well. We can add something like it can have a digit or comma plus, and we can have option in the million or trillion, and we can tell it optional 0 or 1. And the reason why we are doing is it can or cannot be present, so we will be suggested with them as well. So that's the idea of positive look behind, which is assertion. And now we'll do it for time as well. So in time we have the number then followed by AM or PM. So we will be using the look behind. So for that, let me just add a digit plus 1 or more times, and then colon question mark. And now what we are going to do is we will add something like any digit plus, which can be present. Then we'll add question mark equal to. So now we like look forward with anything which is not a white space. Question mark, spaces can be there or not. And then we can have something known as, like if you want to match only the PM, capital PM, and let us close this as well. So we are now suggested with all the PM now. Okay, so you are looking for anything which starts from a space. Okay, your positive look ahead, and I think this colon is for this, right? So we need to match any digit which is 1 or more, maybe 7 or 11, which can be done. Then colon is doubt, so you leave it in question mark. Then you go with plus, and you are positive look ahead. Now you are looking ahead for matching any white space, followed by in the end we have PM or capital PM. We are matching this. So these are some of the assertions, and with this now we go into our Google Colab. So in Google Colab we can connect, and let us start running this. Let us We are all outputs and start freshly. So it's an inbuilt package, so you can just import RE and make it run. So first let us run this import RE, and this is a sentence and this is the pattern. So this will match only one. If you want to search everything, you have to go with search all. So here I am trying to match small a to z, capital A to z, 0 to 9, hyphens. I am escaping that because if you just add hyphen, it is telling the range, right? So it can be one or more times. So it is going to give you using re.search. If you pass the pattern and your text, you get the span and the match as well. Similarly, here we are matching just this date with a forward slash in between. So we are matching. The digit can be like it can be worked with 23, also 2, because in month we can have these multiple combinations, right? This is must 4. So you'll be getting matched even if you go with 12, 12, it will match. If you go with 122, then it will be a problem. Okay. So it matches from here. We need to add word boundary as well so that we can match it. Word boundary. So none. Okay. So if you have just 22, then only you can get it. Okay. So yeah, this should be not here. Yeah, this is a group, right? So this word boundary should be outside of this. Now with 22. Okay, now in this case, okay, since they are numbers, they are not word, maybe we can use the caret symbol to tell that it is at the beginning. So now we are matching, right? So this tells that the beginning of the sentence. So the entire corpus is this, right? So we don't have multiple contents inside. So if you add 122, then it will won't match. It will give you none. Now this will match properly, right? You can even add a dollar symbol. You tell that this is at the beginning or end of the sentence. Here, but inside a corpus, we don't need to use this. Maybe if you want to find any sentence starting with number, you can add this. Then here we are searching for anything which is image, then .png we are searching for. Okay, so we are looking question mark equal to, which is our look ahead and look behind thing, which is our look behind. And what we are doing here is we want to search for ending which can have .png, JPG or GIF, and anything which is not a white space, we are negating this. So any name you will be getting, if it has this, it will match the name and give you. That's why we use this look ahead assertions and all. And this is to match the color code, and color code can be of length 6 or 3. So that's why we use the OR operator. It can be between, it's a hexadecimal code. It's between capital A to F, small a to F, and 0 to 9. So you can match it as well. And then here we are looking for a mail ID, like this is asterisk, can or cannot, which can have multiple things like A to Z, capital A to Z, 0 to 9, dot, underscore, all these things. You can count it, you can have it at, and then followed by any of this, which is must. You want this extra thing, right? Here also I hope we can go with plus instead of asterisk. And then followed by that dot should be present, and it can have anything, but the minimum is 3. You can have .com, .yahoo and all, so you can have a minimum of 3 and maximum of any. Maybe if we add, it is matching the main. And here this will be an issue. If you go with plus, you will get someone if they enter something like at gmail.com. It is telling none, because earlier if you have asterisk here, it will tell you it is a match. It's invalid. Okay, we need to have plus 1 or more. It's invalid. Maybe kj@gmail.com, you get that match. So now a question. So you need to extract. So regex may look complex, but for our NLP task, we will be using it pretty much simple, very easy task only. So the first task here is, I'll do 2. We have 3 tasks. The last one is an assignment for you to complete. So the first task here is you have a text, which is a Twitter text. Okay, you want to just pick all the Twitter handles from it, and we can use this text. And the pattern you can enter and find all. Like find all, since we have multiple tweets, Twitter IDs here. You can see that we have Elon Musk, then Tesserati, Tesla, dummy to Tesla. This is a site, and all the common 6 for them is it starts with this, right? So maybe if you look at this pattern, you'll be getting all the thing which is matching. We want to have remaining of it, right? We can add something like this, a group, now to match anything which is small a to z, capital A to z, 0 to 9, underscore, which should be present one or more times. So if you match this, you will be getting all the IDs which we require. And next thing is you want to extract concentration risk types. It will be appearing concentration risk and then the name will be present. You can see in the text the first type is credit risk, the second type is supply risk. If you want to match this, if you just go with this pattern of concentration risk, you will be getting those two. But we are interested in the remaining things, which is the content after that. Okay. So if you write something like this, something like this new line is to search for new line, but we want to do opposite of it. So I'll use something like negated one, which is not a new line. Once you not entering a new line, here you are entering a new line, which is slash n to go into the next line. So you want to find till that. You want to also add 0 or more, so you can get the concentration risk, which is credit risk and supply risk. And now the third one is an assignment. So companies in Europe reports their financial number. Okay. So you want to extract the quarterly and semi-annual period. So you want to get output as FY 2021 financial year and fiscal year 2021 S1 and Q1. So you want to get this entire thing. So how will you do? You can write your pattern. It will be available in the downloadables. You can enter this and finish this as well. So that's it for regex.